The experimental method is essential to the naturalist approach of analysis for its intrinsic ties to empiricism as a form of reasoning and analysis. It's a methodology that's employed across different schools of sciences and adjacent fields, and essentially the development of the experimental method as it's discussed in its as the chapter outlines it. It's a historical preliminaries. Much of the story of that is a story of its development and shedding of previous ignorances of flaws within the realm of analysis and methods being used to scientifically analyze things. But in that it wants to discuss things that it's not, I think it's fair to point out, just to give another kind of contextual example. It's not mentioned in the chapter, but I feel like it's useful for because it mentions things it's like quasi scientific as compared to like non hard science, and a lot of what we're talking about, like things like the naturalist approach versus like a constructivist approach. Like there's distinctions. People might argue on the lines of like hard science versus like softer science, and then there's other categories that are like purely non-scientific, like abductive reasoning. Things like Occam's razor, I figured might be a good example. A 14th century theologian, William of Occam, proposed this as a way of understanding. It's essentially that it presents the idea that the most simple explanation is most often the most likely explanation, and that often that kind of line of reasoning is invoked as scientific, where it's kind of not. Anyways, the first historic preliminary that's discussed is a discourse revolving around ancient Greek medical practices and anatomic understanding. It was regarded that the eye was the source for light within like the world around any given person. A presence in the lights, and a Persian scientist whose abridged name is shortened to Alhazen was credited as conducting the first observational experiment because he had contrasted the shadows cast by lanterns at distinct vertical placements and differentiations in like the shape and size of shadow would thereby indicate that light does not come from like the eye but outside uh, sources like fire, which is like damn, like that's crazy. Like the, like the understanding of like fire as like a phenomenon precedes like the understanding like, or in some senses, in some cultures, could precede the understanding of like that's where light comes from. Weird. Anyways, the next thing to discuss is the it's kind of an adaptation in some senses, building subtly on the Alhazanian sort of experimental observational method. The chapter then introduces Willem Jacob Gravesend, a Dutch mathematician who was famous for his conducting of a thermal heat sort of experiment, wherein he tried to prove that heat would affect the size of an object. And in this context, there's a little bit more intentional sort of constraints in the experiment to sort of attain something that you can assess and measure. Later on, it thereafter introduces Galileo and his not his heliocentrist sort of revelations, but his dissertation on things related to inertia and like weight and gravity, density, the physics treatise, as it were, and it discusses how he had used a basically like a third party. He had published a dialogue between a series of characters positing as a reflection of apparently, as it's like told that like Galileo had observed a woman. It was apocryphal. Like it observed a woman like from a tower, throwing a bunch of her husband's shit off the roof, and he had concluded like it wouldn't be fair to be able to conduct observations on things, like calculate like the rate of falls compared to one another, with those objects up there based on like the capriciousness. I think the verbiage is used in the text of the wife's throwing cavalierness, not the capriciousness, excuse me. So she's just like hucking his shit. um so there's a lot of like it discusses the importance of like confounding variables and the need for control within an experiment, is a means to like actually analyze and interpret data, and it places an importance on that was like not previously discussed or is previously weighted on. The next experiment discussed is the experiment of James Lind, who is credited for the first intentional therapeutic, like a deliberate therapeutic trial. He, while aboard he sailed on something called like the HMS Salisbury in the 1740s. So pretty non-hygienic practices were standard for ship, and naval travel. And during this time, scurvy was still pretty common for sailors because they're eating like hardtack biscuits and shit because it's like the most easy to preserve thing on a lot of ships, and like a lot of time livestock is not always as practical to bring aboard ships, like certain livestock. But anyways, yeah, Lynn divided. He had like a bunch of people getting scurvy, so he created a bunch of different set groups, with different assigned medical like elixirs and treatments to potentially remedy their scurvy. And the one that emerged successful, the one group that would emerge successful is of course people who were given limes and or a lemon and an orange. Um, and so that was credited as the first establishment of intentional therapeutic trial and deduction. This kind of stresses the importance of not necessarily. I mean, it begins to establish the importance of the randomness of testing and the blindness of at least, well, maybe not blindness, but like the importance of randomization as it relates to testing. The next experiment discussed is the more mathematically involved writings of R.A. Fisher, which discusses his interaction with a woman who would claim that she was able to distinguish the order in which coffee was brewed, like cream, or like coffee first or second, what have you. Um, and one way was incorrect and the other was preferable, and she was adamant that she could make this determination. And R.A. Fisher had described and created a mathematical, like kind of sort of data that explains his null hypothesis, because it introduces the null hypothesis, trying to discredit a presented possibility. And the null hypothesis in this instance is like that there is not an association between um, the guess and if the milk was like poured, before or after. So in this case, it's like a bunch of like, and I'm like particularly challenged when it comes to the verbal explanation of math. So to be honest, like the most simple way to put it is that like he'd arrived at the mathematical understanding that it was inferable that unless she had achieved with 100% accuracy, because they had devised an experiment that they would, with accounting for a lot of confounding variables like room temperature, randomization, things like that, accounting for all this, if she was able to guess with 100% accuracy, that would be the only thing that could, fly in the face of the null hypothesis. Because if like the math would add up, that it's well within the realm of reasonable probability that she could have guessed all but one right. So probability is an important topic. The importance of randomness is also stressed in a hypothetical wherein teachers are presented with a way of trying to teach students, a new way of teachers are tasked with teaching students a new understanding of sociology, and there's like also a group that's tasked with teaching them like a traditional understanding of it. And they had said that they described the importance of very unique and intentional accounts for things that might be like flaws and perceived like randomization. One thing like they discuss, like it would not be truly random to like split the class down the center and say like this is random, because people could be similarly located on the basis of social inclination, thereby like a grouping on the basis of intelligence and anything from like race to class, all kinds of stuff. So that's they're very intentional steps that need to be taken to make things truly random, that almost kind of fly in the face of like just explicit overt randomness, because it's hard to like it's related to in the one's an experimenter's sense of internal validity, that their experimental parameters are correct, and that's discussed with the Hawthorne effect, which was a famous instance where, and this is the final one for this portion, this intro historical preliminary category, but it's a story wherein a Harvard University psychologist is hired by a union boss at a factory to try to assess and create a way that's motivating for its workers. So one group, a control group, is given no um, one group is given like no distinct conditions from when they had started, being observed compared to when they were previously not observed. And then another group is of workers on a different shift is treated with like lunch breaks, cigarette breaks, food. And the idea was, it was assumed that the group that was having their ass kissed and getting special treatment was gonna experience an uptick in productivity, but both groups increased an uptick in productivity. And originally it was like they were kind of confused by that, but then it kind of dawned on them that the reason that there was an uptick in productivity had very little to do with the artificial parameters placed upon them, rather than it was just their knowledge that they were like being observed. And it starts to kind of discuss like the limitations that experimenting on thinking individuals kind of has compared to non. I mean, there's like ethical, and there are, it really like there's hard to account for things. It's like unique human expression, a neurotypical kind of paths that are taken that we can't always account for, and that is kind of the essence of the ever evolving naturalist experimental method.